Right. So we are here and we are asking our friend over at Narragansett Bay Commission, Cynthia Morissette, some more information about the macro that we found inside of the river. So hi, Cynthia. Thanks for joining us today.
Good morning. It's great to be with you.
So we found a bunch of different things when we went inside of the river and would love to find out what the heck we were looking at when we were inside the river and what it means for the health of our river too. Before we look at all the macro, could you tell us a little bit about maybe what you do at NBC and then how macro play a role into that?
Yeah, absolutely. So at the Narragansett Bay Commission, I am the Environmental Education Coordinator, and I am lucky to be able to work with about 800 students in our state, all different areas of Rhode Island. And one of the things that we do is we take field trips to local testing sites, such as the Woonasquatucket River, and we do some critter study and find out what types of macroinvertebrates are living there so that we can find out about the health. We also do some water testing as well. So the water testing combined with macroinvertebrate study can actually give us a really good idea of how the rivers and the ponds and streams in our state are doing. So one of the reasons we study for macroinvertebrates is they can tell us a lot about the health of the water, just as our water quality testing. So there's actually 3 basic groups of macroinvertebrates. There are more, but the ones we use are really to tell us if the water is good to excellent, fair to good, or poor to fair. So really just good, fair, and poor you can think about. So really healthy water that's kind of in between, maybe has a little bit of pollutants, metal pollution, or contaminants from pesticides, and then really poor water quality where nothing would really be able to survive other than leeches and maybe some aquatic worms. So it really gives us a good idea, not only from the water quality standpoint, but from a health standpoint and from a living health standpoint, so the biology of the river. So that's why we study macroinvertebrates.
I would love to what are the types of pieces that you're typically looking for to help yourself identify these macro when you're looking at them?
Yeah, awesome question. So when we're looking at larvae, we're usually looking for particular antennae, or if they have a certain number of legs that can identify them between. There are certain macroinvertebrates that are really tough. They look very similar. So dragonflies, there's lots of species. Sometimes we can tell if certain dragonflies have a fatter abdomen. So abdomen is their kind of bottom piece. So all insects have a head, a thorax, and an abdomen. So they have that head, they have the middle piece where their legs and their wings come out, and then they have abdomen. So if we can identify with antennae, sometimes we have damselflies that have 3 antennae, and then sometimes they have 2. So sometimes we can tell that way. Coloring can tell also. Stoneflies in particular, they have a really cool coloring. They're actually black and yellow, and they kind of have some little dots on them. So, and they're a little bit thicker. Some macroinvertebrates tend to be long and skinny, and some are kind of short and fat. And so that will tell us a little bit whether we're looking at a stonefly or a mayfly. It is really hard to tell. And then just using some really good tools. There are actually some really good identification systems that we use, pictures and items that can identify between lots of different macroinvertebrates. So, but different pieces. So we're looking at all insects have a head, a thorax, and an abdomen, but sometimes some have more little tails coming off of the back. Some have more antennae coming off of the front. So those are good ways to tell the difference.
Nice.
Awesome. Thank you. Let's take a look at all of the different macro that we found when we went along the Woonasquatucket River. So I am going to start sharing my screen so you guys can see all of the critters that we found. So this first picture right here, let's focus in really closely on those 2 worms or worm-like things that we're looking at on our screen.
So those are both aquatic worms, and aquatic worms can be very different in color, sometimes even translucent, where you can actually see the insides of their body really easily. And you can actually, if you look at the one that's stretched out, you can actually see the inside, because a lot of them are translucent. They have a very clear colored outer layer, so you can actually see some of the inside guts and possibly blood and other items inside of that worm, which is kind of neat.
Yeah, this one kind of looks like it's got like almost like a pattern of like
and some of them have different coloring, and then some of them you can see their internal pieces, which is kind of cool. And aquatic worms are very tolerant to pollution, so they can live in just about any type of water body, even when there's pesticides and chemicals, runoff from the streets, low dissolved oxygen. They're very, very tolerant to pollution.
So they're not too picky about where they live then?
They are not at all. No. And the water level can actually be pretty low for them too, because of their need for little level of dissolved oxygen.
Wow. Is that something that you typically find in most environments or in especially polluted environments?
You know what? It actually is something that we find where the river bottom is more sandy. They tend to burrow, so they like areas where there's more sand to burrow into. So we do find those in a lot of ponds and streams where there's a sandy bottom as opposed to a rocky bottom. Mm-hmm. So that might be the area that you were. If there was a sandy bottom, that could be why you found more aquatic worms.
Yeah, it was a little bit of a combo of like the overall underneath was sandy, but there were large rock structures on top of the sand. Awesome. All right. Our next aquatic friend.
The worm on the pants.
So I think that this is just another aquatic worm, or possibly even earthworm. The funny thing is that sometimes regular earthworms will burrow in next to rivers sometimes and can actually be pretty close to the water. So it may have been something that was close to the water that maybe doesn't necessarily live in the water, but it does look worm-like, and I don't see any legs or the 3 parts that an insect has. So my guess is that it's probably not insect larva.
Yeah, and if I recall correctly, we found this worm once we were out of the water and sitting down looking through our samples. So that would definitely make sense.
Yeah, so it definitely could be just another worm, just another earthworm.
Yeah. So when we see worms in our aquatic environments, that's generally a sign of they tend to live wherever they want, right?
They do. So I'm not sure how earthworms differ in terms of, obviously terrestrial as opposed to aquatic. Aquatic worms are all, I shouldn't say all because it never is all, but most species of annelids, so any type of worms, leeches, aquatic worms, all of those creatures are very tolerant to pollution. They need very, very little dissolved oxygen. So that makes it very easy for them to live in low levels of water, and also water that has very little dissolved oxygen. So dissolved oxygen is usually something that we want for our fish species, and then also some of the more sensitive macroinvertebrates. But if they don't need a lot of dissolved oxygen, most creatures can survive in a lot of different types of water quality. High levels of dissolved oxygen are very important for those more sensitive creatures.
Next friend is this little guy right here. You want to tell us about that guy?
So these are actually one of my favorite insects. This is actually a caddisfly. And caddisflies are very cool because there are free-living caddisflies, which live just like a larva. And then there are case-maker caddisflies, which actually build themselves a case. And they're very difficult to find because they look like rocks and sticks and leaves that are in the bottom of the water, because they build themselves a case to protect themselves from getting eaten by fish. These little guys can get eaten by fish very easily because they look like a little tiny worm, but they are very sensitive to pollution because they really have no protection. So finding free-living caddisflies in the water tells you that the water quality is doing really well. It's really healthy, and they do need a lot of dissolved oxygen. So they would be found in areas where the oxygen levels are high or getting higher or progressing to that level, and they're just really, really cool all around. They actually turn into a moth as an adult. So you might see them if you live near a pond or a wetland area. You might see them near light because they're attracted to light just like moths are.
Very cool. And do they make their own case?
They do. So the case makers, and there's lots of variety. There's about 1,400 different species of caddisflies. So the case makers, they have different levels of case making. Some actually turn themselves into look like a snail shell. They'll actually coat themselves with sticky silk and then piece on these rocks and sticks and other items. And then some just have a smooth case or a flat case using whatever's in their environment. So that way, whatever they look like is like their environment for good camouflage for them.
Very cool. It's like their own little engineers.
That's exactly right. They're very cool. That also looks to be, I can't see it totally opened up, so I can't see if it has the correct pieces, but that also looks to be a free-living caddisfly. They actually do have a green, almost a greenish coloring, and sometimes that's actually because of the vegetation that's in the river. They'll actually take on the color of the vegetation just so more camouflage, but they do tend to have a green abdomen, and that looks to be what, because I can kind of see black, almost a black head, and then it looks like it's kind of wrapped up as a green. So I'm not sure exactly, but it does look like it might be another free-living caddisfly. So we are thinking that this is an adult caddisfly since we did find some free-living caddisfly larvae, and so that could be the adult of the larva that you just looked at.
What is a typical lifespan for a caddisfly?
That's a good question. So they can live in the water as a larva longer for up to about 2 years, but once they turn into an adult, they don't survive much past summer. They have similar to most insects, they have a very, very short lifespan. It does depend on species. So, you might have some species that can live a few months. You may have some species that only live for a month. But they're very, very similar to other insects where it's once they turn into that adult, they're not going to live past when it starts to get cold.
Our next critters, I think we should go over all of these guys in on the side, right?
These little critters are in what we call an invasive species. So these are not native to Rhode Island. They have grown and survived and thrived in our local native environment. And we don't really want to kill any living creature, but we also don't want non-native species to take over the area that our native species live, because then they can become more what we call prevalent, which means there's more of them than the native species. So unfortunately, these are not a species of clam that we would like to have in our water here, but they have found a pretty good home here and they thrive. So we find these quite often. Asian clams are actually, they're in the in-between group, so we would say fair water quality, because what clams do is they actually filter water through their bodies. So they're actually taking some of the toxins that are directly in the water and then they're filtering them back out. So they're kind of in between the poor and the fair water quality, but closer to the fair. They would like to live in water that is fairly healthy, that doesn't have a lot of contaminants. But as I said, not really a species we want to have here, but we do. So they've found a way to live in our environment, which sometimes that happens.
Are there any efforts or things going on to help deal with bees as an invasive species, or maybe other macro that we're seeing as invasives?
Right. So a lot of times they will try to find ways that they can alleviate the population increase in some of these creatures. So scientists might take samples and figure out if there's something that they can do, a different type of native species that they can put in that might eat the clam or be able to get rid of the clam. And I do know that there are some birds and other creatures that will actually eat the Asian clam. So I think that they've just tried to not necessarily introduce, but just make sure that, the critters like that are prevalent here. But I think alleviating the transport of these creatures, so Asian clams got here because they attach to the bottom of boats. And so if we could make sure that boats are checked before they're transporting some of their goods, maybe that would be a better way to take these creatures off before they actually come over to this area. So I don't know if you know of any Asian clam programs that they have had. I know a long time ago they did something with the zebra mussel that we also have in the Woonasquatucket. I'm not sure about the Asian clam, but we do find them a lot.
Are there any native species of clams that aren't invasive in the Woonasquatucket?
That's a really good question. There's a pea clam. So, Pete, I don't know if you've seen, they're really tiny. They're about the size of your pinky nail.
Oh my gosh.
And those are actually a species that we do normally find in the water bodies around here. That's one that I know of off the top of my head. That is actually a species here.
Makes sense.
Awesome. Thank you.
Thank you so much.
I think that is all of our critters that we found while we were there. So now that we have all of this information, what are the next steps? How do we calculate the diversity based on what we saw?
So it's a little difficult if you don't have a lot of different species. So if you only have one or two of each of the creatures, although you did find quite a few Asian clams.
Right.
So you know that that's a very prevalent species for the Woonasquatucket in the area that you tested, that you went to do your search.
Right.
Sometimes what we do is, what I do with my students, we actually have a sheet and we have the 3 taxic groups, and then we'll check off how many individual species did we find of each critter, and wherever you find more of those critters, that usually gives you a good idea of how the water quality is. So if most of those critters came from group 1, which is our sensitive category, it would tell you the water's doing really well. If most of the creatures came from group 2, then it's kind of in between. And then if most of the creatures came from group 3, then it tells you that there's probably poor water quality in that area. And sometimes you do find a variety of all 3 groups. It's just a matter of where did you find more of those critters. So we're more in the fair to poor, or we're more in the good to fair, and then you can make your decision that way.
Awesome. Well, thank you so much for joining us this morning.
It's great. It's a little bit of what I get to do, not getting what I get to do. So that's
Yes. We're so happy to have you. It looks like the Woonasquatucket River seems to be doing a little bit better and is more healthy than we imagined or expected. So that's a really wonderful thing for our river.
That's great.
But yeah, thank you so much for joining us and teaching us all about the amazing bugs that live at the bottom of the river.
Yes, anytime. Thank you for having me. It was really a pleasure.